It's Friday early evening in Switzerland. It's Space Café Canada time. Our Space Café Canada by Dr. Jessica West will begin soon. We would like to thank ESA Space Solutions for their great support in our event series. As always, we really appreciate your participation and ongoing feedback, and we constantly learn and improve based on the feedback you give. My name is Chiara Monter. I'm the event coordinator at SpaceWatch.Global and host of the Space Café Benelux, together with my co-host Barnu Bazingi. SpaceWatch is a Switzerland-based online platform for information in and about space and new space activities in a geopolitical context. And with Dr. Jessica West, senior researcher at Project Ploughshares, we have found a great friend and a wonderful host for our outreach in Canada. I know many of you are already familiar with our website and our bi-weekly and daily newsletters and the Space Café podcasts. Our latest episode features Stella Guillen, COO of Germany's hottest launcher startup, ESAR Aerospace. And for all our fans of audio content, we have started with a new format, Space Café Radio, where we'll talk with interesting people on the road, on shows and on conferences. And our first episode is online on our website with Torsten's interview with Rachel Rechev from Endurosat live on stage. And your feedback is always highly appreciated. We also keep our fan shop online open for you to support us actively and become a space watcher. Edition 1 has cool items for you, your friends, and the ones you love. And your support is needed to keep our work alive. We do that for you. If you've missed any of our previous web talks, we have an archive on our webpage in the events section and on our YouTube channel. And we will host our Space Café Canada live regularly. And with that, my job is done, and I would like to hand you over to your host today. Jessica, over to you.
Hi, everyone. Welcome back to Space Café Canada. I'm your host, Jessica West, and I'm joining you from Project Ploughshares. We are a Canadian Peace and Research Institute that has been focused on space governance discussions for 2 decades now. We're located at the University of Waterloo on the Haldimand Tract, which is land that was granted to the Haudenosaunee of the Six Nations of the Grand River and part of the territory of the neutral Anishinaabe and Haudenosaunee peoples. We have a terrific audience today from across Canada as well as internationally, which is exciting. Thank you so much for joining today's discussion called Blinded by the Light. I'm honored to welcome my guest, Dr. Samantha Lawler. Sam is an orbital modeler and observational astronomer at the University of Regina's Campion College, situated on the territories of the Nahiawak, Anishinaabeg, Dakota, Lakota, and Nakota, and the homeland of the Métis-Michif Nation. The University of Regina is on Treaty 4 lands and also has a presence in Treaty 6. Dr. Lawler completed her studies at the California Institute of Technology, Wesleyan University, and the University of British Columbia. She's also held postdocs at the University of Victoria and was a Plaskett Fellow at the National Research Council's Herzberg Astronomy and Astrophysics Research Center, also in Victoria. Dr. Lawler's interests are vast. They include evolution of the Kuiper Belt, exoplanets, planetary habitability, and the artificial satellite visibility. And this later topic is the focus of our show today. Dr. Lawler recently has been at the forefront of new research that models the environmental impacts of emerging mega-constellations of satellites in space. Welcome to Space Café Canada, Sam.
Hi, thanks for having me.
Great. So I thought to get us started that you could tell us a little bit more about yourself as an astronomer, but also what it means to be an orbital modeler.
Yeah. So I kind of came into astronomy. I've always wanted to be an astronomer, like ever since I was a little kid. And the part of astronomy that I found the most interesting, that's sort of drawn me in, is orbit modeling. And so trying to measure real orbits and then try to understand them using computer models, right? So So orbits are pretty simple in that you just need gravity and stepping forward in time, and you can predict where different bodies will be in the future, right? And so, but it gets complicated when you have multiple bodies in the system, right? So that's where it gets really interesting, right? So I specifically study the Kuiper Belt. That's most of what I've done. I also try to use basically Kuiper Belts in other planetary systems to try to find exoplanets that might not be able to be discovered otherwise. So find their presence by looking at weird orbits. So that's kind of my background in coming to this project.
Great. And so your most recent research models the impacts of light pollution from satellites, specifically what we call mega-constellations in space. What are mega-constellations? Why is this trend emerging? And how are they linked to light pollution? That's sort of a lot of questions in one.
Yeah. So mega constellations are sets of thousands or tens of thousands of satellites that all serve a common purpose for the same company, right? And primarily they are for global internet. And so you have probably heard of Starlink. Starlink is currently the largest of these mega constellations that's in operation. They have almost 2,000 satellites, and it's increasing incredibly fast, right? Every time I talk about this, I have to look up how many Starlinks there are, and it's always more. Like, I just talked about this at another university a couple weeks ago, and it's already like many more than last time I looked this up. So Starlinks are increasing in batches of 60 every couple of weeks. They want to increase by batches of 500 soon. So 2,000, almost 2,000 currently. For reference, there's about 3,500 satellites in total, including those Starlinks, right? So Starlink is almost half of all active satellites now, and that's just happened in the last couple of years. It happened very, very quickly. And the problem for light pollution, from a light pollution perspective, is that these satellites are quite shiny and they're in pretty low orbit. So they're not emitting light, they are reflecting sunlight. And you can go outside at night and see them yourself. It used to be that, you would see a satellite fly over, and that was kind of, interesting and special. Like, wow, that's so cool. But we're about to transition, right? It's like 100 years ago when you saw a car drive down your road, and that was a big deal. But now you're living next to an interstate freeway, right? Like, this is the transition that we're about to go through, because there's about to be tens of thousands of these, right? So right now, Starlink has just under 2,000. They want to have 42,000 satellites, right? So many, more than 10 times the current number of satellites for just one company. And there are other companies that want to do similar kind of projects. So that's the reason that I personally became interested in this is a couple of years ago, I got this professor job at the University of Regina. I moved to a farm outside Regina where I can actually see the Milky Way from my back door. It's the first place I've ever lived where I can walk out my back door and see the Milky Way. And I noticed satellites. I noticed them increasing, right? Like, so this project was partly inspired by me wanting to find out, how bad is this going to be when I walk out my back door and look up? How is this going to affect my sky personally? And there's a lot of consequences from all of that. So that's how I got into this project.
Yeah, the highway is a great way to put it, and I see a lot of people in the chat are commenting on this as well. And I remember with the Space Security Index, we'd update the amount of satellites in orbit every year, and it would go up by 200 or 300. And so thinking about 60 every few weeks and going up to hundreds is really a step change from the days when I was counting satellites myself.
Yeah.
So your research is focused on light pollution, and I'm wondering how you go about modeling and measuring light pollution in space, and what's involved in the research process that you're undertaking.
Yeah, so for this, I think it's easier for me to show a few slides to sort of walk you through my process. So I will go ahead and do that. So there's credible progress toward the launching of 65,000 satellites, right? So Starlink is the biggest of these. So gathering up these numbers. So this is the number of satellites in different inclination orbits and different altitudes, right? And there are 4 different companies that are kind of on the forefront of launching many satellites. So we looked at those particular orbits, right? So this is just a table of numbers. So what does that actually look like? So this is a snapshot of over the world of where all of these satellites will be, right? And so over the world, right, there's so many, 65,000 is so many satellites, you can't even really get a feel for how many there are. So here's zoomed in on North America. Right, so this is just a snapshot. You can see that because of the orbits that have been chosen, there are kind of higher density slices. And one of those is right over about latitude 50 degrees north, right? So this doesn't just affect Canada, right? This is worldwide, but I focused on Canada just for like, this is where I started from. So this is I keep coming back to this. Okay, so that's how many satellites there could be on their filed orbits, right? So these aren't just like made up orbits. These are the orbits that companies have said that they are going to use. But how many of those are actually going to be lit up by the sun at any given time? So this is a couple of sort of obscure plots, but so this is showing if you imagine the sun is off in this direction, and so the Earth's shadow is over here, right? So this is like a shell of satellites around the Earth, and some of them are going to be blocked from being sunlit by Earth's shadow, right? So you can imagine standing on a globe underneath this shell of satellites. How many sunlit satellites will you see in the sky at any given time? And of course, sometimes it will be daytime, so you won't actually see them, right? And so that's what this more complicated plot is. It's showing latitude versus hours since midnight, right? So here's midnight, right? So this is the shadow of the Earth blocking satellites. You can't see very many. The colors represent how many sunlit satellites will be in your sky at different latitudes and different times of night, right? So this is thousands, right? The yellow is thousands of sunlit satellites above your head in your sky from this point right here, close to sunset, right? So I'll break this down into a more digestible format, but this is kind of terrifying just at first, right? So this is where we're starting from with the model. But how bright, so now we know how many sunlit satellites there are above your location on Earth at any time of night. But how bright the satellites are actually depends on a lot of unknown engineering. So we wanted, my latest paper was with 2 other Canadian astronomers, right? So we're all pretty close to this latitude 50 degrees. We're all very concerned about this problem. So we wanted to use observations from a Canadian telescope, the Plaskett telescope in Victoria. And we caught some Starlink satellites, right? So you can look up when different satellites will be flying through your field of view. So these are real images from this telescope. So they're long time exposure, right? So these satellites are moving pretty quickly across the sky, kind of like the same, a little bit faster than a jet flies across the sky at altitude. So point the telescope where we know a satellite's going to fly through, and that's that streak. So over the course of a minute or so, it flies across well, it only flies across here over a few seconds, but the exposures are about a minute. So you can see that they're quite bright compared to background stars, right? And so then we measure these brightnesses and we use that to calibrate a model. So basically the gray is our model, the blue is our real observations, and all that you need to know from this is that we have a model that matches our real observations. So we're trying to be very realistic about this. So we know that this model that we've come up with for satellite brightnesses matches Starlink's, and we don't know if that's a good approximation for future satellites or a bad. Like, is that optimistic or pessimistic? We don't know, because we don't know if other companies will do a better job or a worse job than SpaceX has done. Note that so most of these are naked eye visible still, right? Like SpaceX has stated that they want to make their satellites fainter than you can see with your naked eye, but from these observations, so the blue, the real observations, the vast majority of these are still naked eye visible. So they have not met that goal yet. Okay, so we take this model, we take our list of orbits, we take orbit code, right? Because these are satellites, they're in orbit. I know about orbit, so that's great. And this is what we produce. So this is sort of a grid of predictions. So we did these for many places on Earth. I'm just going to show you a couple of them for reference. So this is for Hawaii. This is evening. So right when it's starting to get dark, midnight, and right when it's starting to get light in the morning in this direction, right? And then this is different seasons. So the winter solstice, the equinox, and the summer solstice in this direction, right? So another way of looking at this, I'll just show you. So the summer solstice is the worst. So you can see that at midnight, and then the color is showing you how bright these satellites are. So this is where they will be in your sky, right? So this is a full sky view, eastern horizon, western horizon, southern, northern. And the dots are satellites that will be in your sky from Hawaii. And so you can see at midnight, and the color shows how bright they are. The orange and the yellow ones are visible to the naked eye. So you can see that, and then there's a number down here that tells you how many are visible, right? So it's hundreds are visible to the naked eye, close to sunrise and sunset. At midnight, you can see there's almost none, except in the summer. There are a few, and they're very faint, just close to the horizon. So now I will show you a movie of basically the same thing. So this is on the solstice from Hawaii. This is the whole night sky, right? And here's the time as we go through the evening. This is the number that are sunlit up here. This is the number that are visible, right? So you can see that there's a good chunk of the night where there are no visible satellites and only a few faint ones that will cause problems for telescopes, right? So that's one of the reasons that I've picked Hawaii for this, is because a lot of major astronomy research facilities are on Mauna Kea, including some that I use. So this is for Hawaii. And then if we go to, so this is for Canada, this is for latitude 50 degrees north. This is the same for Europe in latitude 50 degrees north. And so same grid of predictions, right? So now you can see for midnight, in the summertime, the number of visible satellites does not actually change during the night. So from Canada in the summertime, we will have hundreds of visible satellites all night long. And so that's what this movie is showing also. So I started the movie a little early, right? It's not actually dark at 9 p.m. on the summer solstice from 50 degrees north. It's around 10 p.m., right? So this is right, and so remember, the orange and the yellow dots are the ones that you could see, and you can see that most of those are directly overhead all night long in the summertime, right? So this isn't going to be blocking like it's not going to completely block out the stars, but there will be hundreds of satellites that are moving in front of the stars all night long in the summertime, which is the best time for observing, right? Like our nights are short, but it's a lot nicer than observing in the winter, right? Okay, I think that like did a whole bunch of, sorry, that was a lot of things all at once, but that was a long answer to your question.
No, but it hit home. I took my kids camping in southern Ontario, so we're probably very bad for light pollution from Earth, and it's hard to see the stars here. And they got excited because they saw one, but it was moving across the sky, and I was like, that's a satellite. And so trying to think about that times hundreds and thousands of what we were looking at. And I'm not an astronomer, and so you're an astronomer, and obviously this research is coming out of the astronomical community. Why? Actually, I'm going to merge my question with Chris in the chat because we were kind of thinking the same thing. Is this just a problem? Is it a problem of reflecting light, or is it a problem of obstruction? And why is it a challenge for astronomy? What's the issue here?
Yeah. Okay. So very quickly, I also want to hit the point that, you talk about going camping and getting away from urban light pollution, right? Like, so this light pollution, you cannot get away from, right? That was something that our simulations showed. It will be worldwide, right? There is no more going camping to get away from light pollution. It's everywhere, right? So that's one of the worst parts about this particular light pollution. So the brightness of the satellite, right? So they're reflected. So sorry, can you say the question again for the reflection? So
someone is asking, is this, and maybe it's a twofold problem. Is the problem reflection of light, or is it obstruction from physical things in the way, or both?
So it depends on the kind of astronomy that you're doing, right? So for naked eye observing, just going out and enjoying the stars, it's definitely just the reflection that is the problem. For certain types of astronomy, like we sometimes try to find exoplanets or measure Kuiper Belt objects or asteroids by stars getting blocked. Right. And so that kind of measurement could be affected once, like, it sounds crazy because they'll pass in front of stars with just, like very, very quickly, fraction of a second. Right. But when you're measuring a tiny Kuiper Belt object that's really, really far away, it also only passes in front of a star for a fraction of a second, right? So you could be getting false positives from these. You could be changing your measurements, right? So it's a new source of noise. So there is a small fraction of astronomy observations that will be affected by these satellites blocking stars, but mostly it's just a reflection problem. So the reflection problem for stargazing, it's just going to be distracting and annoying, right? Like these simulations are predicting somewhere between 1 in 10 to 1 in 15 points in the sky will actually be a satellite, not a star, right? 1 in 10, right? That's crazy to think about, it being that bad. But for astronomy, these are much brighter than what we're trying to find for research astronomy. So like the Kuiper Belt objects that I look for are 15 million times fainter than a typical satellite that will fly through the field of view, right? So that's going to make it much trickier to find these really faint objects that we look for, particularly in wide field images, right, which is what I need to find new Kuiper Belt objects, or to study distant galaxies, or right, like there's a lot of very faint things that we look for, and some of the satellites are so bright that they could potentially even damage the very sensitive cameras on these telescopes, right? So the same kind of science will still be possible, but it will require more time because a lot of your exposures will be messed up by satellites flying through.
And is this a challenge that only affects the field of astronomy, or are there sort of ripple effects on other areas of space science or other users and uses of space?
Well,
or in other words, why is astronomy so important?
Right. Yeah. And I'm really partial to the importance of naked eye stargazing, right? Like that's something that humans have been doing for thousands, like as long as we've been human, right? Like we look at the sky and watch these patterns in the sky, and there's so much traditional knowledge that's wrapped up in, when certain constellations are visible and when, certain events happen around the world, right? And suddenly we're going to have this human-made pattern that is much more noticeable than the natural patterns that we've had access to for thousands of years. So that's something that really deeply bothers me, and that transition is happening like right now. I mean, it's going to happen very quickly, and I think that's a huge piece of humanity that we're losing, and that really deeply worries me.
And you mentioned that this is worldwide. Is it worse in some places? Is it a challenge that particularly affects Canadians, or is it the same everywhere?
So within a couple hours of sunrise and sunset, worldwide, any time of year, there will be hundreds of satellites in the night sky, anywhere in the world. But because of the geometry and of the sun and the seasons and the orbits that have been chosen, latitude 50 degrees north and south, both parts of the world, are the worst places in the world. If you go further north than latitude 50, there's not quite as many satellites just because of the orbits that have been chosen, right? Like their market is clearly not the far north, not enough users to justify it, I guess. So the number of sunlit satellites goes down just because of that choice. And also, like in the summertime, it doesn't ever get fully dark, right? And that's when they're most sunlit. Here at 50 degrees, we do get some darkness, but it'll be full of satellites all summer long, right? So it does affect Canada and Europe, places that have people living at high population densities at latitude 50 degrees, which is mostly in the north. There's not so much at 50 degrees south. There are people there, but not huge population densities. So it does affect us more than other places in the world.
Yeah, because that is where the vast majority of the Canadian population lives.
Yeah, exactly. Right on the border.
Right on the border. It's within 100 kilometers, which is probably right at latitude 50. So are there technical fixes for the light portion of this, or would those not really mitigate the challenges that are posed to astronomy and other space sciences?
Yeah, I mean, so I think really like the only thing that can truly 100% help is fewer satellites, right? But that being said, it could be a lot less bad if satellite companies put more energy into trying to mitigate the reflections, right? So SpaceX has voluntarily changed the design of some of their satellites. They added visors to them to make them less reflective. They also tried basically painting one of them black early on. And this is voluntarily in response to outcry from astronomers and other people who appreciate the night sky. So I am very grateful that they tried that, but like the black one actually fried itself. It got too hot, and the visors, they did make them fainter, but not fainter enough. And it's not clear if they are continuing to use that on their next generation of satellites, right? Like there's a lot of lack of communication. So astronomers just, we don't know what they're doing. They're just launching stuff, and we see it in our images and like, darn, that's really bright. Right, there's not a lot of information we have beforehand. So, there are absolutely fantastic engineers who work at all of these companies, not just SpaceX. And I have no doubt that if they were told that they needed to meet some brightness limit, they could do it, right? But they aren't being told that. So it's not a priority. So they're not doing it. So I do think that we could make it a lot less bad if the engineers who are designing the satellites have this as a priority. But so far, that is not the case. There's absolutely nothing that is making them do that.
Great. I want to ask one more question before we actually elaborate this point, which is really what you're talking about, the meeting of engineering and technology with policy and governance. We'll dive into that in just a second, because your research is also about more than light pollution. That's not the only impact of mega constellations in space. What are some of the other environmental risks that come out of this really vastly intensifying use of outer space?
Yeah, so Kessler syndrome, right, and space junk. I think that's something that you have talked a lot about in this series. But just having more stuff up there is going to cause major problems for collisions between satellites and between space junk and satellites. That makes more space junk, right? Like it's not. If you look at like a map of where all the satellites are, here I can actually show that. This is from a recent paper by Boley and Byers. Right. So this is the density of stuff in orbit. All right. Both space junk and operational satellites. Versus altitude, right? And you can, these little green lines, those are already like the Starlink satellite shells that are filling, right? So you can see these are much higher density than anything around them. And the blue is tracked space junk, right? Just bits of rockets and bolts and whatever, right? And so all of these are going to spiral in slowly due to atmospheric drag, right? Like this is quite high altitude, but there is a little tiny bit of atmospheric drag at these altitudes, right? So all of this junk is eventually going to cross these spikes, right? And this is only the tracked space junk. There's a whole bunch of much smaller, many smaller particles that are not tracked. They're too small to be tracked that also have to cross these shells, right? And SpaceX has said that their satellites have active autonomous avoidance and they won't crash into anything, but I'm not convinced. This has not been demonstrated, right? And we're coming up to solar maximum, right? The solar activity is the sun goes through a cycle every 11 years where it has more activity or less activity. Right now we're close to minimum. But we're ramping up. So 2024 is predicted to be the next solar maximum. That's about when SpaceX will have, many thousands more satellites. These, more solar flares means that more satellites get knocked out or put into safe mode. So what happens when thousands of satellites that have to actively avoid each other are suddenly shut down for a few hours by a solar flare, right? Like, that seems like a recipe for disaster in orbit. So that's one problem. Another big problem is that, pollution from launches, right? Many more satellites means many more launches. This is depositing all sorts of rocket, what's the right word? Exhaust in the upper atmosphere. And these satellites are planned to deorbit, right? SpaceX plans to have their entire fleet of Starlinks need to be replaced every 5 years. So 42,000 satellites getting replaced every 5 years means that they're going to be deorbiting 25 a day. They're going to burn up in the upper atmosphere. And deposit, like that material doesn't go away, right? It gets deposited in the upper atmosphere. The satellites are mostly aluminum. depositing, so that's like 6 tons of mostly aluminum per day added to the upper atmosphere. Like, what is that going to do? Like, nobody knows. Nobody has modeled this. There's low Earth orbit is not considered an environment, so there's no environmental assessment that has been done for this. This is just an experiment that SpaceX is going to run with no environmental oversight, right? So that is extremely worrying to me.
Yes, and I've read about this, but I have not appreciated, I don't think until right now, how extensive the implications are. So let's talk about what we do, because you, as well as some of your co-authors, Aaron Boley and others, you were part of a group of astronomers that submitted recommendations to the Canadian government and the Canadian Space Agency in response to a call for feedback on the future of Canadian space exploration. But you focused on this issue, and I'm wondering if you could share some of the recommendations that you were urging for the Canadian government.
Yeah, so the these recommendations are like, we have to be really careful because obviously, this is something that we haven't actually talked about at all yet, but like, these satellites offer a very valuable service to a lot of people, right? Like, they are to provide global internet, and particularly like Northern Canada, there are a lot of people who have been very much left behind by, broadband developments, and they have really crappy internet options. And especially during the pandemic, where lots of people are working from home and taking classes from home, it's vital to have access to fast internet, right? So this is, there is a benefit to all of this, right? But the important part is to take into account all of the possible negatives also, right? The externalities, right? What are we going to lose by gaining this one service? And that those losses will happen for everyone, regardless of whether they use those services, right? So these recommendations we have to be very careful about, because Canada doesn't have a lot of leverage here at all, right? Like, if Canada made a bunch of rules that says, oh, well, you have to pay a whole bunch of money because you're destroying the night sky in order to get access to our customers, they could just say, nah, not worth it, not that many customers, right? So you can't be really heavy-handed in any rules, because they can just ignore it, right? There's no international regulation here. So there's a lot of this that has to be done together with other countries, right? And you have to be really careful not to start having, flag of convenience states, like that's another possibility, right? If everywhere in the world except one little country somewhere says that you have to follow these strict rules, then all the space companies will launch from there or set up shop there, right? And not have to follow these rules. So this has to be done internationally. But some of the recommendations just are to take into account these externalities, to consult with people, to tell them what they could lose by gaining this service, right? Particularly, this is an issue, particularly, like I said, for Northern Canada, which has a very high fraction of Indigenous people, right? First Nations need to be consulted, right? This is one of the recommendations of the Truth and Reconciliation Commission calls to action, right, is that Indigenous people need to be consulted when their resources are being developed, right? And the night sky could totally be considered, a right that has traditional knowledge wrapped up in it, right? And that is something that they would be losing by gaining this service, right? But they also might really need internet access, right? So consultation is really important for many different stakeholders in Canada. And that's not happening at all right now, right? The satellites are just launching. And so figuring out some way to address these externalities, and this is way beyond my little tiny bit of policy expertise, and then also trying to support astronomers, right? Canada has invested a lot in astronomy, right? We have access to some of the best telescopes in the world. Like, I don't want to brag, but like Canadian astronomers are awesome. Like, we're really good. Like, we do a lot of research output with not as much, more research per government dollar than a lot of other places in the world, right? We're really good at that. But the Canadian government has invested a lot here, and if we suddenly can't do as much astronomy research, then we need support to develop algorithms to get rid of these satellite trails, or better, like radio astronomy is going to be even more severely affected. And Canadian radio astronomy is also extremely strong, not just optical astronomy. So developing hardware, which Canada's already very good at, but more support to develop better hardware to filter out the radio emissions from these many new satellites that are going to be interfering with radio astronomy, right? So just like monetary support for astronomers is one thing. Consultation is really, really important. And it can't be done alone, right? It has to be done internationally.
Yeah, and I'm all for more money for Canadian astronomers. I think we should just write a few more letters for that. And peace researchers, we'll just throw those in too, lump them together.
Definitely.
So I think what I find so fascinating about this topic is it's something I only kind of knew a little about, because I focus more on the global level. As you were saying, this is really an international issue, and space debris is very much a topic of focus. We're maybe still not doing the best job of addressing it, but at least we talk about it at the global level. But light pollution, not so much. But I was excited to see that you and COPUS worked on a dark skies report, and seems to at least be starting the conversation, but it's just not getting the same amount of traction as other sustainability issues are. So hopefully we'll start waving the flag of pay attention to this.
Yeah. The thing that I worry about, right, is that all these international regulations are extremely slow, right? And SpaceX is launching 60 new satellites every couple of weeks, right? Like, this is happening now. And by the time any sort of regulations get through, there will be tens of thousands of satellites already, right? So a lot of this, the light pollution issue is depends on these companies cooperating with astronomers and talking to astronomers. And so far, SpaceX, OneWeb, and Kuiper have all been very good at talking with astronomers, right? But there are many other companies who have not been, and they haven't talked to astronomers at all, or we have no idea what their plans are, right? So we can't just rely on companies to be good and make these changes just because we ask nicely. We do need international regulation, but I don't know if it'll come fast enough.
Well, it seems like we're already behind.
Yeah. Oh yeah, for sure. Yeah. Yeah.
I have more questions, but I do want to take a step back just to ask another question from the Q&A, which was more technical, and because I don't want to leave people behind in the conversation. And so there was a question about why so many satellites for the services provided, and B, why certain orbits are important. And I imagine having that background filled in might be helpful for following along.
Okay. So let me just say that this is something I am not an expert on. This is just from reading articles. But my understanding is that you want to have many options for many options to point your satellite dish at as they fly over. And when you use lower orbits, you need more, right? We'll see. So if you took all of the satellites and moved them to much lower orbits, you would see fewer of them in your sky, which means that in order to have the same number of satellites above a customer, you need to have more satellites, right? So astronomers have recommended that companies go to lower orbits because for some particular science cases that is better because they're brighter, but they're moving faster, right? So if you're doing a long time exposure and the satellite moves through your field of view faster, it's much better because it smears that same brightness across more pixels, right? So it's less of a problem. So just having them at lower orbits means more satellites are needed. I don't know exactly like how many satellites need to be overhead for someone to get good internet. And then the orbits that are chosen are related to that, right? So the orbits are all relative to the Earth's equator, right? So you have, the Earth, and you have to choose different inclination orbits, right? And where they turn around is kind of the furthest north and south that you can provide lots of service, right? And clearly from the orbits that have been chosen, they're not super interested in the far north. There's probably not enough people up there to be worth it for them. So the orbits that have been chosen are clearly primarily to reach the middle latitudes where most people live.
Except the far north has more of the infrastructure gap when it comes to access
exactly
to internet, and that's the way I have seen projects justified.
Yeah, they do use that a lot, don't they? But that is clearly not the goal.
Okay, which I'm just realizing now.
Yeah.
Okay, sorry, there's a lot spinning through my mind in terms of questions.
And also this is changing all the time, right? Like even, I submitted this paper a week ago, right? And SpaceX has already changed what orbits they filed for in that time, right? Like it's just changing all the time. So it's a moving target.
I'll give another shout out to the Dark and Quiet Skies, because apparently there's going to be a second edition coming out. So I'm glad this is a conversation beyond Space Café Canada and beyond your research, which is good. You mentioned sort of astronomers had to make a lot of noise on this issue and almost had to get companies themselves to engage with you because there's no global governance or national governance. And as you said, low Earth orbit is not treated as an environment. And I find that fascinating, and I need to dive into that in a different episode. But what are the challenges you face? Is science and astronomy, I guess, how do we trade off values and uses and make these decisions about what we use, what kind of externalities we tolerate, and who pays for the externalities? And is science something that we're giving enough value to in space?
Yeah, that is an excellent question. And so I personally have not been involved in reaching out to companies and trying to get them to talk to astronomers. I have participated in conferences where other people have pulled them in. And I'm very grateful that the mega constellation companies have sent representatives to these conferences. That's fantastic, because that's a lot of the only way that astronomers find out about what the plans are. Like I said, SpaceX did voluntarily change their design. But yeah, how do you get people to value that, right? Like a lot of people, most people in the world live in very light polluted places where they don't see the stars. So they won't notice this change until they get out and go camping or something, right? But a lot of people don't do that, right? So how do you get people to care about something that they don't see? that's a tricky one. And how do you put a value on that, right? Like this is, not just astronomy research and potential interesting discoveries, but like human knowledge over thousands of years. How do you put a value on that as an externality, right? Like I have no idea. that is much beyond me as an astronomer. But those are the questions that we have to be talking about in policy discussions, right?
So I'm going to incorporate another audience question into my question. Some of you are reading my mind, which is fun. So we've talked about governance at the national level and the role of astronomers and government and companies. And then we've talked a little bit about COPUS and the international. And someone is asking about the role of amateur astronomers and what regular people, or even people like me that just try to get a glimpse of the night sky as best I can, might do to help out on this issue, or to promote it or whatnot.
Yeah, I am so glad you asked this. But yeah, like, so you know, these large corporations like SpaceX and these other companies, they will only respond to legislation or consumer pressure, right? And that is the thing that has worked so far, is consumer pressure, right? So use your power as an individual consumer, right? If you are in a position that you can afford it, that you have other options for good internet, do not buy satellite internet, right? Like, that is flexing your power as a consumer. If you do, right, if you don't have any other options and that's what you want, tell your satellite company that the night sky is important to you, right? That they will listen to you as a customer if many people have the same concern, right? And, you know, telling people what is happening, because most people have no idea that this is coming. Most people won't notice it until next time they go camping, if they do that, right? Which, you know, there'll be 1,000 more satellites by then, maybe. And talking to your government representatives, right? Like, a lot of the reason for this is because a lot of rural and remote places have been left behind by internet development. So supporting other ways of getting internet, right? Like, I live quite a ways outside the city on a farm. I am fortunate that I have the infrastructure for cell tower internet. And that's fantastic, right? I don't have to rely on satellite internet, but that infrastructure is not available in many places. I am completely aware of that, right? So support it. Tell your governments that you want them to invest in other ways of getting internet, not rely on one American private company for this infrastructure that should be a government provided service, right? And then for amateur astronomers, show people the night sky, right? Like, if you have a telescope, show people what they will be missing in the next few years with satellites flying in front of it, right? Because, you know, and I know a lot of amateur astronomers are fantastic at this, and I so appreciate it. Just showing kids the sky, showing people, members of the general public who've never looked at Saturn through a telescope or something, how amazing it is, right? Like, getting people to care about the sky, and also going out and enjoying it yourself, right? That's another important thing you can do, is just, you know, reaffirm to yourself how important it is to you.
Yes, I did do that. I did that this summer.
Excellent.
As I'm surrounded by cities, it's very hard to get a good glimpse. And the difference between looking at the sky in southern Ontario and we went to Sleeping Giant Provincial Park near Thunder Bay, which is a dark sky preserve. And it's quite different. But now I'm realizing that if I ever make it back there again, the view that I have is not going to be the same. And the light that I see is going to be in many cases artificial. And it just feels like I feel sad. I feel like I'm losing something. Yeah. And that my children are maybe losing something as they go, you know, get older and hopefully appreciate the sky, but don't have the experiences I had.
Yeah. I mean, I think about that a lot. I don't want my kids to grow up with seeing 1 in 10 points in the sky are actually satellites, not stars, right? That's awful.
I do want to ask one more technical question, because I don't want to ignore Lockie in the audience. And I'm worried that by asking this, I'm not sure if you can see the Q&A, so I'm going to do my best to read it, because Lockie's fantastic with technical stuff and I'm not. So he said that OneWeb satellites are smaller in size than Starlink, 4 meters, 2 meters, 30 meters. Did the plots that you showed earlier, did they assume that all of the space objects are the same area a special
Yes.
area as Starlink? Because was that part of, sorry, and that's a very specific research.
No, that's a very good question, and that's actually something that I'm addressing for the referee report on the paper. So good job. Maybe you're the referee. We did just assume that everything was the same as Starlink, right? Because we could have done a set of observations of OneWeb satellites also, but there's not quite as many of them. Like that's like another project to try to observe those. And there are published papers that compare the two brightnesses. So OneWeb is a little bit fainter at the same, and they are also at higher altitudes mostly. So they're probably not as bad. But we don't actually know until we get there and observe it, right? So we picked this one model because it works for Starlinks, and we don't know if that's pessimistic or optimistic for future satellites, right? So we just had to pick something. Yeah, that's an excellent question. And so hopefully, I've never wanted to be wrong more badly on a published paper, but like I hope that I'm wrong, right? Like I hope that other companies will do a better job of making their satellites fainter or smaller or something, right? This is very doable, but it's not a priority for them right now.
Right, and that comes down to that question of cost. I mean, Torsten noted that, the internet itself from space is very expensive because it costs a lot to build and maintain the satellite systems, the ground stations, the receivers needed. And so it's not a bargain financially, but for some, it's an only option. And yet if we were to start incorporating sort of the externalities, if you want to be an economist, into the cost, when you think about it that way, it's much, much higher, but we're not very good at
doing
that. I mean, we don't do that for pollution. And we're still struggling to find a way to do that with debris as well. But thinking about how we might cost things in a way that you pay for true value, but also that you account for externalities seems like a good way to go, but probably kind of hard.
Yes. Yeah, definitely. And that's something that has to be set by countries that license these with the current system. It has to be set by the countries who license these constellations to broadcast to their country, right? That's the only power that individual companies have over these. And they can always just say, nope, don't want to do that.
So I'm going to circle back to Canada again, because this was a letter. Did you ever hear back? Has there been any response from the Canadian government? Now, I also wrote a letter, not on light pollution, obviously, but I didn't hear back. But has there been discussion at the official level from Canada that you're aware of? And maybe it's not something you follow, but are you met with silence, or are you starting to get the attention of people?
So we wrote this letter with recommendations, and they did invite us, like myself and Professor Erin Bully, to do a consultation with a wide range of government representatives, right? There was like Department of National Defense, there was CSA, obviously, there was Global Affairs Canada, there was it was a whole wide range of people. So that was fantastic that they were actually, and Natural Resources Canada also, right? Like this is very similar to a lot of like mining pollution issues, right? Like very similar kind of externality framework. So so they listened to us. I got a couple of emails from people following up afterwards, and I haven't really heard anything since then. But they did actually meet with us, and that was fantastic. That was a really good first step. I know Canada is actively involved in negotiations at the UN level for light pollution issues. I don't know exactly where that is right now. That's not the side of things that I follow very closely, but it is happening, right? Like these discussions are happening. It's just very slow.
Yeah, and I feel like there's a need I mean, what struck me is how many different government departments have a role to play in Canada when it comes to space. And I think that's hard to appreciate, maybe if you're in a different country or in a different industry where it tends to be sort of one key department. But in Canada, it's really diffuse and it's a lot of actors. But globally as well. So I'll just point out that one of the questions and comments was about, the ITU, and sort of maybe we can start also thinking creatively about the roles that different governance organizations at the international level play, and giving voice, I suppose, to more organizations that also have experience with regulation. Many, like 2 centuries experience with regulation. Instead of always going back to the starting line.
Definitely.
I'm just making sure I haven't left anyone out. More questions about Canada. I follow, someone asked who follows these things. I follow what Canada does at the UN on space. So reach out if you have questions. I haven't followed this topic too closely because it's not a huge focus at COPUS. It's not been one of the priorities, but the priorities at COPUS change over time as different states parties introduce new issues and build coalitions of support, among others. And I'm hoping that this might get more pickup, especially as Chris points out, another Dark Skies report coming out. UNUSA, the UN Office of Outer Space Affairs, working on this, and really a coming together of voices for an issue that can be hard to understand from the ground as a regular person and as a non-technical person. And as you said, we might not realize what we've lost until it's kind of gone. And that would be really unfortunate. I think we've kind of hit them all, and I am aware that I promote the event as 1 hour. So I might take the opportunity to thank you. I thought I knew something about the topic, and I did know a little bit, but I certainly know a lot more now. And I just really appreciate your ability to explain things in a way that's accessible and exciting. The chat has been great. The audience has been terrific. And so I want to say thank you for taking the time to be with us. But don't go anywhere, because this is usually the point when we hand it back over to Kara and our friends at SpaceWatch.Global on the production side.
And let me just say thank you, everyone, for watching, and go outside and enjoy your night sky.
Yes, and try to get out of Southern Ontario if that's where you are. The difference is phenomenal.
Thank you so much for this great talk. It was really wonderful, and also with the slides, your explanations, it made it very, easy to understand for someone who's also not from a technical background. So I think it's been quite inspirational, and I definitely feel like I want to go stargazing now. So before I let you go, I would love to mention our upcoming events. So next week, Tuesday, on the 28th of September at 4 p.m. CST, we have our 33 Minutes with Robin Geis, which will be live from the UNIDIR, from the Outer Space Security Conference in Geneva. So tune in for that. It will be really interesting. And sticking to the topic of astronomy, on the 5th of October at 4 p.m. CST, we have our 33 Minutes with Mike Simmons from Astronomers Without Borders, who will be discussing how astronomy can be used to bring the overview effect to humanity here on Earth. So as always, all our events are going live on Eventbrite. And we would love to hear your feedback. So please check in with us on Twitter, Facebook, and LinkedIn. Don't forget to sign up to our daily or bi-weekly newsletters of SpaceWatch.Global. And if you want to treat yourself with something special, become a Space Watcher today. Your support will help us greatly. So just take out your credit card and visit our fan shop at shop.spacewatch.global. And I know we say this quite often, but we do need your support to continue our work. Thank you, everyone in the audience, for showing your interest today, for asking so many great questions and being active in the chat. And of course, a huge thank you to Jessica and Samantha for this inspiring talk and for being our guests. And thanks to the entire team behind the scenes for doing that great job week in and week out. Also, huge thank you to ESA Space Solution for their great support. I hope that you all stay safe and stay healthy. Thanks again for joining us. I hope to see you in the next weeks. And in the meantime, visit our website and follow us on social media. And don't forget, become a space watcher. Thank you so much.